Good afternoon, everyone. We have a wonderful speaker today. I've heard Mark's talk in the past. So our speaker is Mark Longstrauth from Michigan State University. He most recently was a small fruit extension educator in Southwest Michigan until he retired, I think, what, a few weeks ago, Mark? So he's doing a talk on twig blight with blueberries. It's real important. I know we have a lot of issues with that in New England. So hopefully he'll hit on all these for you. And I'm going to turn this over to Mark.
All right. Well, it's a pleasure to be here and give this talk. That's what I used to look like. Retired. I've been retired for 8 days. And so I learned quite a bit about blueberries. I knew absolutely nothing about blueberries before I came to Michigan, but worked with them for the last 27 years, so I've seen quite a bit. I'm going to review blueberry shoot growth because blueberries grow kind of unusually compared to other fruit crops that we grow. I'm going to talk about pruning and sanitation. I'm going to talk about the different diseases that we have here in Michigan that cause twig blights and shoot blights, and then I'm going to review it all at the end, and then we'll have time for questions again. So I'd like to talk about the cycle of annual shoot growth, and I'm going to go through that with pictures, and then we'll come back and talk about the different diseases that infect blueberries. So right now we've got dormant shoots out there, and with blueberries, the flower bud is normally at the tip of the shoot, and we may have more flower buds underneath it, but we've got vegetative buds underneath that. And soon here in Michigan, it'll be in March, late March, early April, the flowers will begin to swell and the buds will break and the green tissue will be exposed. And this is usually about the time here in Michigan when we're putting on our first fungicide sprays to control mummyberry and Phomopsis as that green tissue is first exposed. Break dormancy, the growth starts at the shoot tip. So you can see that the flower bud has started to expand, and below it is a leaf bud that's got about a 1/4 inch green. Below it, there's another one with a little bit less green and a little bit less green. So growth started at the tip and went on down. And as the flower buds open and the shoots grow really fast and everything starts moving really fast in the springtime when it warms up. So here's an example of blueberries here in Michigan. These are both taken off the same bush at the same time. The one on the left, the shoot tip was broken or cut off. And you can see in the one on the right how the progression of growth has occurred, where the flowers at the tip have already bloomed and set fruit. The ones right below it are in bloom now, and below those are flower clusters that haven't even opened yet. And below those are all the different vegetative shoots that will grow. We get real rapid growth in the springtime, and the shoots grow real quickly, competing with the fruit. And generally, about the time the shoots are 8 to 12 inches long, we get a hot day, and if you're out there, you'll get to see this. This is about the only time in the season that I ever see blueberries wilt, and they will wilt, and it seems like soon after that, the shoot growth stops. It's almost like there's a signal sent inside the plant that says, okay, we've used all the water up that the plant can provide on a hot day. So we see the shoot tip die, and the carbohydrate reserves from the leaves go not to new shoot growth, but to expanding the fruit. So I get an awful lot of calls from people say, you know, the shoot tips are black. And if that's happening in late June or July, I go, that's normal. You know, the shoot tip dies. And that bud right below it, you can see here the bud that has formed in the axil of this leaf will become the new terminal bud. And there's a bud in the axil of every leaf all the way down the shoot. And that's where new growth will take place in the springtime or next year. So generally, I can tell real quickly when I'm out in the field if there are new leaves coming from the ends of the shoots, then that means that I've still got actively growing shoots. But if there are no new small leaves, then I know that shoot growth has pretty much stopped. We may see another flush of growth late in the summer after harvest. But here in the Midwest and the Northeast, we usually get one really good flush of growth, and then in the late summer we get a second one. Out in the West Coast they get 3 or 4, which is the reason why they do so much better than us in so many ways. So late summer growth is the fruits ripening and the flower buds begin to form on the shoots. And so here's a picture of late summer growth, and you can see the flower clusters there at the bottom of the picture where we've got shoots, and then you can see the leafy shoots above it. And what's going to happen is after those fruit are picked, there are no leaves there, so there are no buds there. And so that shoot is going to die back to the next leafy shoot. And so that shoot tip is going to die back. And so in the springtime, you might go out and you'll see these dead shoot tips at the beginning. And so here's a picture I was sent earlier this spring. And those are actually the flower trusses from the previous year. Those are the trusses that held the fruit and they haven't fallen off yet. And you can see the shoot tip has died back to the next leafy shoot. So you get this shoot progression of the shoots blooming at the tip and then branching at the base. And so then those shoots bloom at the tip and they branch at the base. And as the shoots age, those, or as you know, as the major shoot ages, those branching shoots get smaller and shorter, and the leaves and the fruit on those shoots get smaller and shorter as well. And over time, you end up with this really twiggy mess with a multitude of old dead fruiting shoots that to me, when I look at that and people complain about getting shoot blights, and I say, well, you're not pruning hard enough. Look at all those places where you can get spores from where infections have occurred in the past. So I like to talk an awful lot about pruning. I find that most blueberry growers are afraid to prune very hard. They can see those very visible fruit buds and they look at that and they think, oh, look at all that fruit. I don't want to prune that fruit off. And so they've got this old twiggy wood that in my mind just produces small fruit and small leaves. It's not really wants to pick that stuff. And we want to remove those older canes and force growth into new wood that's going to be more fruitful. We get a better distribution of fruit buds if we avoid those lots of short shoots. So here's a close-up of what the shoot tips look like on those, on that blue crop bush on the right. And you can see that on this one, you know, there's a fruit bud there, and I think bud there, where here we've got 6 or 8 fruit buds on each shoot. And that's really what we want, is to grow lots of large fruit. So you have to remember that blueberries only fruit on last year's shoots, and the fruit buds are located at the shoots. And if we got vigorous shoots, we have lots of flowers, we can grow a vigorous crop of new shoots and fairly large berries. But when we get to the point where the canes are more than about 6 years old, then we have lots of little short shoots that might have 1 or 2 fruit buds on it and maybe 1 or 2 leaf buds. So that instead of these big, large, vigorous shoots, we get these little short shoots with little leaves on them, and we get little fruit. So as I say, all that old dead fruiting tissue can serve as a reservoir for pathogens to reinoculate the new tissues that come out each spring. And so we have diseases here in Michigan, and I'm sure you do too, like Phomopsis and Anthracnose, that are spread by rain splash. And so if we've got old dead twigs that were killed by those diseases, they can still spread spores from those diseases. And anytime it rains, then those spores rain down on the green tissues below them. In addition to getting rid of the reservoir of spores or reducing the reservoir of spores, we can open that spray canopy up for better spray penetration, and we get faster drying time if we open the thing up. So for twig blights, our major spring disease here in Michigan is mummyberry, and following that is Phomopsis and Anthracnose, and occasionally I've seen bacterial canker ones here, but I think it's more of a problem where you're at than it is here in our situation. So generally twig blights are more of a problem in fields that are poorly pruned. In fact, the berry pathologist here doesn't want his fungicide trials pruned at all, so he has more old dead wood, you know, in the trials and a higher spore load. As I said, all those harbor old infections and are a source of spores for further infections. Anytime we have wet, rainy springs with frequent infection periods, that sets up conditions for severe twig blight infections. I've been working in blueberries for about 27 years, and I've seen 2 years when twig blights were very common everywhere, but in general, you can find them someplace every year. And I believe that those infections occur pretty early in shoot development, soon after bud break. So I find mummyberry to be a very interesting disease because it has to infect the plant twice. And so it overwinters as mummy on the floor of the field. And the upper left-hand corner, you can see mummyberry mummy with 3 apothecium. My growers call them mushrooms. I call them. It's just a sac fungi, and it puts out those spores, and they float through the air and will land on green shoot tissue. And if there's a wetting period, they'll infect that shoot tissue and they will kill the shoot. And then the spores are carried from the infected shoots to the flowers and infect the fruit. And then the fruit is infected, shrivels off, and the disease cycle repeats every year. So generally here in Michigan, we're spraying about 4 times a year, 4 times in the early spring for control. So here's an example of the life cycle of mummyberry from the mummy on the floor, the sat fungi, the apothecium that infects the shoot, and then the shoot becomes covered with the spores of the mummyberry fungus, and it looks to a bee kind of like the flower cluster of blueberries. You can see in that upper photo right in the center that it does sort of kind of resemble. So they'll go visit those shoot strikes and carry the spores from the shoot strike, which also happen to be sweet apparently, to the flowers. And if they infect the flower early on, within a day or 2 of when it opens, they can become mummyberries and then continue the cycle. So for us, that's a big thing that we spray for. So here's an example of mummyberry shoot strikes, and you can see all those dead shoots on this blueberry cane. And the way I tell if it's mummyberry, one is the fact that you've got that white fungal mycelium over them, but the disease does not go into the woody part of the shoot. It only kills the new green tissue, and it goes back and it doesn't go into the wood at all. And so that's my quickest way. I can get out and I can look, and if it doesn't go into the woody tissue, if it's got these fuzzy spores on it, it's mummyberry. It's not Phomopsis. So for mummyberry control, these are the materials I recommend. The frac code 3s, Endar, Tilt, Quash, and Proline all give really good control of shoot strike and the fruit rot phase. And generally, oftentimes, we will swap back and forth. I often tell my growers to use Tilt early in the season for shoot strike control and save Endar for the bloom period. We have a label restriction for Endar to that it can only be applied 4 times. And if you have a wet, rainy spring, then it can be a real problem. We often mix in Bravo or Zyram in those early shoot strike sprays to try and provide some longer control. We think the frac code 3s, Endar, and Tilt only last for about 5 or 7 days. So if I see the infection going down into the wood, I know that that's not mummyberry. That's actually Phomopsis, and probably Phomopsis, and that infection may have taken place in the springtime, or it may have taken place in the previous fall when the flower buds were forming. And so here's an example of the shoot tips, pardon me, not the shoot tips, but the flower clusters that were infected being killed, and the infection you can see moving into the woody part of the stem. So when I see that, I say, oh, that's either Phomopsis or Anthracnose, and you can see right up here to the left of the Phomopsis is an old dead shoot tip, which probably rained spores down on this during the wet, rainy spring. It's killed the shoot back to here, and now we've got some really nice new growth taken over where the plant's trying to compensate for that. So, fortunately for us, the fret code 3s work really well against Phomopsis as well. And the time when we would be treating for mummyberry is the same time that we would be treating for Phomopsis in the early spring. And so those are the same type of materials that we use on both of those diseases. We're real lucky in the fact that the same fungicide does an excellent job on both of them. That's not always the case. So the early season spring shoot diseases, Phomopsis generally seems to infect the flowers and the shoots. It often starts at the tips of the shoots that will die back, or we'll see buds that we think were infected last fall or buds that are infected early this spring. Anthracnose we think of more as a fruit rot disease, but it also sometimes infects the shoots. And so it's kind of galling when you're sitting here, and I'll come back to that. I'm going to talk about each of these diseases individually. And so generally, it's either Phomopsis or Anthracnose that's the cause when we've got a lot of twig blights. And both diseases overwinter on dead twigs and are dispersed by rain splash. I think of Phomopsis more as a cool weather disease and Anthracnose more as a warm weather disease. And the fruit anthracnose infections probably come from infected twigs. Oops. So, yep, here's an example of twig dieback, and so what caused that? And we're going like, I have no idea. So here's another example. We had a really wet spring. I can't remember. It was about 10 years ago. They all run together for me, and we had all kinds of shoot blights coming. And so when I first saw this, it looked a little bit like Phomopsis, the way the entire cane will go down with Phomopsis. And when I looked at it a little closer, you can see right here is where the infection started. And here's a close-up of it. And so these little black pimples are called pycnidia, and they're fruiting bodies of the fungus. And so the fungus started there, infected that leaf, which is unusual, and then that canker spread and killed the shoot above it. And so generally when I see white spores on spring dieback, I think of Phomopsis as the causal agent. It could be botrytis, but we hardly ever see botrytis around here, but and you would have to key it out. But generally, if I see white spores, I think in Phomopsis or botrytis. If I see orange spores, I'm thinking anthracnose. And so this one I think is anthracnose, though I'm not quite sure because I don't have a blow up of this one, but right there where the tissue is going from dead to alive on the left where in the box, I think I can see orange spores, and I don't see an awful lot of white spores, and I don't see the black pycnidia. So here's the life cycle of anthracnose, where the tissues are encrusted. I shouldn't say encrusted, but there are spores from all the infected fruit that cover stems and can infect buds or old fruit trusses, any tissues that are dying like these old stems. And then in the spring, the sporulation starts and they can infect the fruit again. So we really focus on fruit infection, and when it's a big problem for us, but if we have the right conditions, if we have a lot of rain and warm conditions, we can see some twig blight and trace it back to anthracnose. And the crazy thing is that when you go, we've got a section in our spray recommendations that talks about the susceptibility of different cultivars to anthracnose. And then you'll go out and you'll visit somebody who has a real twig blight problem, and you'll take samples and send them in, and it comes back and they say, well, it's anthracnose. And you go like, but that variety doesn't get anthracnose. It's relatively resistant or not as susceptible. And all those comparisons are really being made on the fruit, not the woody green tissues. So here's the different materials that we would use for different things. And when I first started in this job, it was really frustrating to me. So I can only imagine how frustrating it is to growers that you can't use the same fungicide for everything, that there are different types of fungi. And Endar, which works really good for mummyberry and Phomopsis, is not even worth putting in the spray tank if you're trying to control anthracnose. Where Abound or Pristine, which are in frac code 11 or mixtures with frac code 11, are fair against mummyberry and Phomopsis, but excellent against anthracnose. You often have to mix one or two high price spreads in order to get good control of more than one disease. So Lifeguard down at the bottom, I don't remember what exactly is in it, but it is a biological. Serenade is a biological. We've had fair luck with it for mummyberry and Phomopsis. It's not in this table, but many of my growers use lime sulfur in the fall and the spring for Phomopsis control. Captan is, fair against mummyberry and Phomopsis and a little bit better against anthracnose. And we have a special local needs here in Michigan, so we can use Xyram at a 4-pound rate, which is 1 pound higher than the labeled rate for on the national label. And it works well for us. We often mix either Captan or Xyram in with the early season sprays to give us a protectant to go with this systemic. And then we've got Psudomonads, twig blight. And so this is caused by a bacteria. And I had never seen it before. And we had a grower that had really bad twig blight. And I went out there with the plant pathologist when we were looking around. And the guy had had a really tight Endar schedule. So he shouldn't have had mummyberry or Phomopsis. And yet it was abundant. The samples went back to the lab and they came back with no fungi on them. So that told us that it was indeed Pseudomonads. And I do know that in New England and in New York, this has become a problem, but we very seldom see it. And so generally the clue is that it's really dark. You know, the twig blight is almost black. And in many of the twig blights, you can see it's brown. You can see that those tissues have turned black. They're not brown. We generally see more Pseudomonads syringae in cherries or in blueberries when we have spring freezes that damage the tissue, and then the bacteria can get into the damaged tissue and begin to grow. And so because it's a bacteria, fungicides don't work at all. And so generally we use copper, and perhaps some bacterial biocontrol materials can use, but many of my growers will use copper sprays early in the season just as a broad spectrum fungicide. Unfortunately, copper is not something that we generally look at for its control of other fungi. So I couldn't tell you how effective I was looking. I can't tell you how effective the copper is against mummyberry and Phomopsis or anthracnose, because it just hasn't been tested. I want to talk a little bit about anthracnose fruit rot here, because this is what most people are controlling. And so generally, we don't see this disease show up until relatively late, just before harvest. We begin to see anthracnose fruit rot, but the infection actually takes place soon after bloom, when we've got really small, rapidly growing green fruit, and we get an infection of the fruit, and that just stays latent, waiting on the fruit until we get to the point in time where it begins to ripen, and then the fungi can colonize the fruit much more effectively, and then it spreads from fruit to fruit to fruit. It's really easy to protect the green fruit against relatively easy to protect the green fruit against anthracnose. Some of the systemic materials you can spray on 3 or 4 days after an infection event and still get good control. But once the fruit starts to ripen, it is impossible to get any, we call it back action from sprays. You have to have protectant sprays or systemic sprays on before the infection to protect blue fruit. And so you can see that the infection is just waiting dormant here in the green fruit until it gets going. And it's this late season infection. And anthracnose or Choletotricum is a very common fungus. It causes fruit rots in apples and many other fruits. And so it's very abundant. And so you just have to assume that it's around all the time and focus your sprays on. We just really focus our sprays on controlling the fruit rot phase with sprays really focused on it right after bloom. That's our major problem. And so here is a graph of spore release. And so the blue line is the amount of rain, but the orange columns are the number of spores that are released. So you can see early in the springtime, we get a huge number of spores that are being released from infected twigs and last year's fruit trusses. And that this is the main source of infection for the fruit. And then later when the berries come on, I would guess that this person had a halfway decent spray program because he doesn't have a very big release of spores from the ripe berries at harvest time. So when we're looking at summer fungicides, these are the things that we look at in blueberries. Phomopsis is not really something we spray for. We're really spraying for anthracnose and alternaria. Those are our main two fungal diseases. And alternaria is really more of a disease that if you leave the fruit on the bush too long, you get alternaria. And I don't have a slide in here, but it seems like if you do a good job of controlling anthracnose, you kind of set the plant up or the fruit up for alternaria. And if you do a good job of controlling alternaria, you kind of set the fruit up for anthracnose. It's like, you know, if I remove one competitor, then the other one has a greater chance to colonize the fruit. I want to talk a little bit more about Phomopsis here, stem canker. And for us, it is really a frustrating disease because the stems will suddenly die in the summertime. It's extremely hard to control. I mean, there's no spray I can tell you at this point in time that this will fix it. Our go-to recommendation is just remove and dispose of the dead and diseased wood. Here's a field in Michigan, and so they'll go out there and they'll cut it all out, and then you'll get you'll think, okay, I got rid of it all and more will come. And so you can see here that there are dark shoots, and then there are these yellow shoots, or pardon me, orange shoots. And if you look real hard, you can probably even find some that are starting to go down, where they just go down one after another. I'll get calls from people that say it's wiping my field out, and I'll come and show up and there'll be like 400, 500 plants and 5 or 6 strikes, and I'll go, just cut it out and carry it away. That's our best bet for controlling Phomopsis. But this disease is probably coming from infected shoot tips that get onto wounds of some kind or another on the base of the main stem, and then the main stem collapses. So we've got some varieties that are very susceptible, and we generally have diseased twigs or canes in the bush. We may have rainy summer. I don't think that's a big deal, but I do think that when we have winter injury or frost injury, it kind of sets us up. When I go out and look at fields and look at Phomopsis canes that have been killed, about half the time I can find a wound down where the canker is, but the other half of the time I can't. So I can't say that it's caused only by wounding, it's caused by something else. We may spray an herbicide on the base of the cane and cause some problems there. So we may have some stress there. Hopefully you guys don't have shoestring virus, but any other kind of stress, drought, 1 year could lead to more Phomopsis the next year. A hard winter, when we get down to -10, -15 degrees, my growers get real excited about winter injury, and oftentimes after we have a bad winter, we'll have worse Phomopsis cane injury the following year. And we see it quite a bit in the base of the plant where we've got new shoots coming, and then the shoot gets sick and it dies. And so that silvery region of the plant right there is what I look for if I'm looking for Phomopsis. If it was just this, if it was just a dead shoot tip with no area where there might be fungal infections, I would say it's winter injury. Oftentimes we'll see an area down here that is just a light brown, a doe, deer colored thing. And I'm often wrong. I'll take samples like this, and generally I'll think, oh, this is all Phomopsis, and it'll come back in and it'll be anthracnose. But generally, I look for a white area on the stem, and if there is a white area, I'm thinking it's probably Phomopsis, maybe anthracnose. If it's not there, it's winter injury. All right, so to reduce twig blights, I think it's really important to follow good sanitation practices, do good pruning to reduce those old infections and reduce the spore load and the possibility of having an infection. For disease control, I'm thinking for mummyberry, I want to use FRAC3 fungicides early. For Phomopsis, I want to use FRAC3 fungicides early. For anthracnose, the FRAC11s, the strobilurins, work really good are the protectants, and generally I wouldn't want to use those before bloom unless I had really warm, wet conditions. If bacterial canker is my main problem, then I would be using copper sprays early. I feel that cooler, wetter conditions favor Phomopsis and warmer conditions favor anthracnose, and both of them are out there. So when do I start? I start at bud break. When that green tissue is exposed to infection, and the first protectant sprays for mummyberry and Phomopsis go on at that time. In New Jersey, they use a different system than we do for naming their buds, and theirs is called T3, and it's just when the flower bud begins to open and those bud scales are separating at the tip, that's when they think their first Phomopsis spray should go on. So if I thought anthracnose was my problem, I'd probably wait a little longer. I'd wait until the flower buds had opened, until we're what we call pink bud, where the flowers are exposed. If I have warm rains at that time, I would think about perhaps controlling anthracnose. And if I have a problem, I'd certainly want to have samples tested for disease to have it ID'd so I could fine tune my work for later. So that is it.